Welcome back to part 2 of Trig Notes 1.5 or part 2 of Pre-Calc Notes 4.5. The last video kind of got cut off when I was trying to show you how to graph a -3 sine of x, so I'm going to kind of start that process over. Here's what the graph looked like when we graphed a 3 sine of x, so that's the graph in blue. What I'm going to graph now is the -3 sine of x. So the graph is going to have the same x values here. The only thing that's going to be different is that normally the sine will start at the origin and it will go up to the top of the amplitude. If you have a -3, it makes it go down instead. So the -3 makes the graph go down. So instead of it'll still start here, but instead of it going up to the top of the amplitude, it's going to go down to the bottom of the amplitude at the next x value. Then it'll come back up to the middle, go back up to the top of the amplitude, and then back down to the middle. And so the graph would look like this. And then if I continue that pattern the other way, I'm going to go up, down, down, and then back up. And get my curve that way. So the green graph is now when you have a -3 on the front. So I'm just putting them on the same axis, so I didn't have to go through and rewrite all of these x values again. So what's important to know is that when you have a negative number or a negative amplitude, the graph will go in the opposite direction. Negative amplitude graph goes opposite direction. And again, that's something that's worth highlighting or something that's worth noting for a test or a quiz. Okay, so looking at this next example, if we are trying to graph this sine graph, I like to write down the generic form of the equation. Y equals a sine of bx plus c plus d, because that gives me a good idea of what exactly my a, b, c, and d. So I know my a value would be a 1, because it's the imaginary 1 in front of the sine. B is a number out in front of the x. 2. C is what I'm adding to x. In this case, it says minus pi over 3. And I'm recognizing that I've got a mistake in my formula here. This should be a minus, not a plus. It's bx minus c, not plus c. So that means that my c value is pi over 3, and d is going to be a 3. So my formula is over here. I take the absolute value of a, I take the 2 pi over b, I take the c over b, I take the d, and now I can find the amplitude of 1. Period would be 2 pi over 2, which is just pi. Phase shift would be pi over 3 divided by 2. So pi over 3 divided by 2 is pi over 6. And my vertical shift is 3. So I haven't had a vertical shift or a phase shift yet when I've graphed these. So here's how you want to deal with that. First thing you need to recognize is that the sine normally starts at the origin and goes up. Now because I have a positive amplitude, it will go up. But because I have a phase shift of pi over 3, instead of it starting at the origin, now it's going to start at pi over 6. I think I said pi over 3. So since my phase shift is pi over 6, I'm going to have to actually start my graph going pi over 6 to the right. So my graph is actually going to start here. This will be my first dot. Actually, that won't be my first dot because I actually have a vertical shift as well. So my vertical shift would take my first dot off of this x-axis and move it up 3. So if this is where 3 is, my first dot is going to be at pi over 6, 3, right here. Now whenever I have a vertical shift, what I like to kind of do is draw a dashed line through here. And this is really going to represent where our x-axis, even though I'm still going to put all my numbers on the x-axis down here, but that helps me understand that I have to go above and below a distance of my amplitude. So that means I'm going to have to go up to 4, since I have to go up amplitude of 1, and I have to go down to 2, since I have to go down an amplitude of 1. So my graph is going to be trapped between 4 and 2 here. It's not going to be right on the x-axis like it was before. because of this 3 phase shift or vertical shift. So I've gone from 0, 0 up to 0, 3 here. So here's my first dot. To find the next numbers on here, what I need to do is take my period and divide by 4. So my period divided by 4 would be pi over 4. So I need to add pi over 4 to this. So in my calculator, what I'm going to do is I'm going to do 1/6 plus 1/4 to get my next number here for the x-axis. So typing that into my calculator, I get 5/12. So I know my next number would be 5 pi over 12. Then to get the next one, I'll take 5 over 12 and I'll add 1/4 to that. And doing that, I get 2/3. So if that's 2/3, this would be 2 pi over 3. Okay, do it again. So take 2/3 now and add 1/4 to that. I get 11 pi, or I get 11 over 12. So this would be 11 pi over 12. I've got to do that one more time, so I get 4 sections here. So if I do it one more time, I would do 11 over 12, and I'd add 1/4. Doing that, I'm going to get 7/6. So that would be 7 pi over 6. So now when I make my graph, here's was my starting point. I'm going to go up to the top of the amplitude at my next one. Then I come back down to the middle here. Then I go to the bottom of the amplitude at the next number on the x-axis, and then I go back up here. So this graph, one period of the graph will look like this. Now I need to get my second period, which is going to go backwards. So take this starting point, 1/6, and if we were adding 1/4 before, let's subtract 1/4. So 1/6 minus 1/4 ends up being a negative 1/12. So if it's negative 1/12, my next point would be right about here, negative pi over 12. Then take negative 1/12 and subtract 1/4 from that. You get negative 1/3. So your next point would be negative pi over 3. Let's subtract 1/4 from that. And when I do that, I end up with negative 7/12. So this would be negative 7 pi over 12. And I've got to do that one more time to get my fourth dot here. So if I do negative 7/12 and I subtract 1/4, I end up with negative 5/6. So this becomes negative 5 pi over 6. And if I continue the pattern now, the next dot will come over here at the bottom of the amplitude at negative pi over 12. The next one comes back up to the middle, then I go back to the top of the amplitude, and then I come back down here. So the graph will look like this. What a lot of students will do is they'll assume their next dot is going to be at 0, 0. It's not going to be at 0, 0 here because of this phase shift. So when I subtract 1/4 from 1/6, I go past the 0, 0, and that's why my first dot, I'm going backwards, is at negative pi over 12. And so that's what two of these periods would look like. Again, this is typically the hardest portion of these, is getting the numbers on the x-axis here. And the way that you can do that is take your period and divide it by 4, and then start adding that number to the starting spot, and start subtracting that number from the starting spot to get all of the numbers here. The last thing I needed to do was talk about where it ended, where one period ended. The first period ended at this dot right here. Here's the starting spot. One cycle was right here, so that is the coordinate point 7 pi over 6, comma 3. Okay, so next graph is a cosine graph. So let's write the generic form up across the top here. A cosine of bx minus c plus d. And now we can identify our a, b, c, and d's. So our a value is going to be 2/3. Our b value, now notice the way that this is written. This is written as x divided by 2. I'm going to just change it to write it as 1/2 x, because that's really what this is. X divided by 2, the number that's being multiplied by the x is a 1/2. I think by writing it like this, we tend to not make mistakes and write the x value as a 2. Sorry, the b value as a 2, not the x value. Recognize here that my x value is a 1/2 instead of a 2. And then my c value is going to be pi over 4. And my d value, I have nothing I'm adding to the outside, would be 0 or none. So the formulas, absolute value of a, 2 pi over b, c over b, and d. So the amplitude would be 2/3. The period, 2 pi over b, 2 pi over 1/2. So to solve this, to get rid of this 1/2, what I'm going to do is I'm going to get rid of that by timesing by 2, and that's going to make my period be 4 pi. My phase shift is c, pi over 4, divided by b, and the b is 1/2. So again, to get rid of the 1/2, I'm going to get rid of that by timesing by 2, so I'm going to get pi over 2 when I do this. And then I have no vertical shift. So, with the cosine graph, what I need to remember is that the cosine starts at the top of the amplitude. So it starts at the top of the amplitude, but for this graph there is a phase shift of pi over 2. So since it's a positive pi over 2, I move this way pi over 2. My amplitude is 2/3, so I'm just going to draw this up here and say that that's 2/3. I'm not going to worry about putting a 1 up there and then trying to figure out where 2/3 is. And we'll go down to negative 2/3. So my graph is actually going to start at the top of this amplitude here. So that coordinate point would be pi over 2, comma 2/3. Now to figure out where it ends, what we want to do is take our period and divide by 4. So 4 pi divided by 4 ends up giving us pi. So really what I'm going to do is I'm going to take 1/2, which is my starting spot, and I'm going to add, because this is really 1 pi, I'm going to add 1 to that. So that makes 3/2. So my next point would be 3 pi over 2. To that 3/2, I'll add 1, and that's going to make 5/2. So my next point would be 5 pi over 2. To that 5/2, I'm going to add 1, and that's going to make 7/2. And then I got to do that one more time, so to 7/2, I'll add 1, and that makes 9/2. So that's going to be 9 pi over 2. So if you're asking yourself how many times you need to do this, once you have your starting spot, you need to do it 4 times to be able to get your 4 numbers here. Again, once you have your starting spot, so you don't include that number. And then here's the pattern for the cosine graph. It starts at the top of the amplitude, comes back down to the middle, and then goes all the way back down to the bottom of the amplitude. Then it comes back up to the middle, and then back up to the top of the amplitude. So the curve would look like that. If I follow this pattern going backwards now, continuing the same process, for the second one I'd start off with 1/2, and now instead of adding 1, I'd subtract 1. So I would be at negative 1/2. So this would be negative pi over 2. Then I take negative 1/2 and I subtract 1, and that's negative 3 pi, or just negative 3/2, so it'd be negative 3 pi over 2. So what I'm noticing here is that it looks like my pattern is going to just repeat going backwards. That's not always going to be the case, so I would still recommend trying to solve these out to get your answer. But for this one, that is the case. The next one would be negative 5 pi over 2, and the next one would be 7 pi, negative 7 pi over 2. And then I'd stop there because I've got my 4 numbers. So if I continue the pattern, my graph would look like that. The last thing I want to do is put my ending point. So this is my starting point. That was my ending point on my first period. That was 9 pi over 2, comma 2/3.